Hi, I'm Mike Marin, and in this video we'll talk about creating vectors and matrices in R and performing some simple operations on these. Recall that we can assign a value to an object in R using the equal sign or by creating an arrow. Here we'll assign the value 11 to the object x. Often we would like to create a vector or a column of numbers or characters. We can create a vector in R using the C or concatenate command. Let's create an object called x1 and we'll store in this a vector of values 1, 3, 5, 7, and 9. Here we can see these are now stored in the object x1. We can also create a vector of character elements by including quotations around the characters. For example, let's create an object gender and we'll store in it the elements male and the element female. We can create a sequence of integer values using the colon. For example, creating a sequence running from 2 up to 7, taking on only integer values. For more general sequences, we can use the seq command. Here, let's create a sequence running from 1 to 7 in increments of 1. If we would like a sequence of non-integer values, say a sequence running from 1 to 7 in increments of a third, or a sequence running from 1 up to 7 in increments of 0.25. We can use the rep command to create a vector of repeated numbers or characters. Let's create a vector repeating the number 1, and let's repeat this 10 times. We may also create a vector of repeated characters. Here, let's repeat the characters Marin, and let's repeat this 5 times. We may want to have a sequence repeated multiple times. For example, we may want to repeat the sequence of numbers 1 to 3 and have this repeated 5 times. Or we may want to repeat a sequence of numbers for which non-integer values are used. For example, a sequence running from 2 up to 5 in increments of 0.25. And let's have this repeated 5 times. We may also want to have a sequence of characters repeated multiple times. For example, we may want to repeat the characters M and the character F and have this repeated, say, 5 times. Let's go ahead and create a vector called x with a sequence of numbers running from 1 to 5. And let's also create a vector called y with the numbers 1, 3, 5, 7, and 9. We'll demonstrate a few things on x and y in a moment. First, we may add a value to each element of the vector using the plus command. For example, we may want to take the object x or the vector x and add 10 to every element in this vector. Similarly, we can subtract 10 from every element in this vector. We can also multiply each element of this vector by a constant, or divide each element of this vector by a constant. If two vectors are of the same length, we may add, subtract, multiply, or divide corresponding elements. Recall, we had the vector x and the vector y. Since these two vectors are of the same length, we may add them in an element-wise fashion. We can subtract the two, again in an element-wise fashion. We can multiply corresponding elements, or we can divide the corresponding elements. It is worth noting here that slightly different commands are used in order to perform vector or matrix multiplication in a linear algebra sense. We may extract elements of a vector using square brackets. Recall the vector x and the vector y. Here we will extract some elements from the vector y. If we would like to extract the third element in this vector y, we can place a 3 within the square brackets. Here we can see we've extracted the third element, which is the number 5. Including a negative sign, we'll extract all elements except the third element. We may wish to take y and extract the first 3 elements. We may wish to extract the first and the 5th element. Or we may wish to extract all elements except the 1st and 5th. Finally, we may wish to take y and extract only the elements where y is less than 6. That is, for the vector y, only extract the elements that are less than 6. We can create a matrix of values using the matrix command. Let's go ahead and construct a matrix, and here we will have the values 1, 2, 3, 4, 5, 6, 7, 8, 9. We will set the n row argument equal to 3, letting R know we would like a matrix with 3 rows and hence 3 columns. And we can set the by row argument equal to true. Note that this must be capital letters to let R know to enter these elements row-wise. We can see if we set the by row argument equal to false, these elements will be entered in a column-wise fashion. Let's go ahead and store this matrix in an object called MAT. We can use the square brackets in a similar fashion to extract certain elements from this matrix. For example, if we would like to extract the element in the first row in the second column, we can also extract multiple elements from this matrix. For example, we may want to extract elements in row 1 and row 3 and column 2. Leaving a row or a column blank or empty will extract that entire row or column. For example, we can go into the object MAT or a matrix, extract row 2, all columns. This will extract all of the elements in row 2. Now, let's go ahead and extract from this matrix all rows and just column 1. As we saw with vectors, we can perform element-wise addition, subtraction, multiplication, or division. Here we can take our matrix and multiply every element by 10. In the next video, we'll discuss importing data into R and working with a set of data. Thanks for watching this video, and make sure to check out my other instructional videos.